I am Frederick Nundu, the CEO and owner of T3DP Corp. I'm here to record a video of our problem statement and solution. I hope it will be effective. Our problem statement: cost barriers and market competition. While traditional flat solar panels are widely adopted, the cost barriers are significant. Although Chinese manufacturers have optimized efficiency and scalability, achieving low module prices of $0.11 per watt, the US market remains far less competitive. US solar module prices are $0.31 per watt, almost a 300% premium over global prices. The real cost of residential solar installations in the US, after accounting for a 27% solar loan dealer-free, reaches $4 per watt, creating an LCOE of 0.133 per kilowatt hour. This is around parity with the average electricity rate of $12.925 kilowatt per hour apps in Arizona, making it difficult for solar to compete in the energy market and limiting widespread adoption, global competitiveness, and domestic demand. Despite thriving, global solar markets in the US faces higher costs due to domestic manufacturing and logistical challenges, creating an urgent need for affordable technology. Our 3D solar modules priced at $0.075 per watt offer a competitive, scalable alternative, undercutting both US and global prices. This positions our technology to overcome the economic barriers to widespread adoption in the US. We also have the dark curve, a major challenge in solar requiring energy storage and grid integration. Another problem is the material waste and environmental impact. Our solution: we are developing novel textured glass substrates with different textured 3D shapes such as sinusoidal and other various shaped structures which can be used for textured solar cells. The Tennessee Valley Authority TVA, the largest electricity utility in the USA and one of our first stakeholders from Texas, TN Industries of the Future, needs 10 gigawatts of solar by 2035 and needs our 3D solar like yesterday. What really sets it apart and makes it hard to copy our mousetrap is our room temperature glass casting process efficiently creates 3D microstructures in the glass substrate surface before the solar cell is made. This enables homeowners to see an ROE in 1 to 2 years instead of the typical 9 to 11 years, while cutting their electricity bills in half. By doing this, we effectively increase the surface area of the solar cell, dramatically improving its energy power density and off-axis performance. With the Inflation Reduction Act subsidy on module, LCOE per kilowatt hour will be cheaper than fossil fuel extraction. We achieve this through balance of system cost reduction through the use of recycled glass waste materials, which is a third of our cost, reducing environmental impact and costs. Our manufacturing approach bypasses expensive lithography by using relatively low-cost glass manufacturing. Historically, BP Oil commercialized flat 3DTE solar modules in the 2000s using electroplating to deposit the CDTE. We are working with Jim Bako from www.artcraftplanting.com, who was involved with BP's electroplating process to plate CDTE. For us, the Colorado School of Mines also had a program where they were electroplating CDTE. Research shows CDTE can electroplate faster at higher temperatures with larger crystals grain growth. Our micro 3D textured glass solar substrate technology is compatible with CDTE, CIGS, perovskite and silicon active materials, and our initial results are promising with CDTE compared with silicon. We believe we can lower the amount of tellurium used per watt by up to 5 times addressing the bottleneck in tellurium availability. This could increase the global production of CDTE solar power from 20 to 25 gigawatts to over 100 plus gigawatts annually. Key benefits of our 3D solar technology driven by Western Coast. Winter forecast issues are resolved. 3D textured surfaces captures more sunlight during mornings and evenings, extending solar generation from 7 a.m. to 7 p.m. Our design provides an effective solution to California's DICDAV problem. Delivers 15 to 100% more power compared to flat solar cells using the same ground area. The 3D structure dissipates heat efficiently, resulting in a 39% increase in power generation, particularly beneficial in hot climates, reducing CDTE thickness from 4 to 5 pm to 8 nm to 1 ohm, enabling 125 plus GW of CDTE solar module production annually. Thank you. Welcome all. Thank you once again. Frederick Nundu, CEO, owner T3DP Corp.